Hi future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to study the 210 websites, 1,155 book pages, 1,700 Quizlet flashcards, and 291 videos and podcasts included in the GISCI recommended study material like I did when I passed the GISP exam. In this video, I'm going to teach you everything I learned about database design when I studied for the GISP exam. Database design is the second section under the Database Design and Management category of the GISCI Geospatial Core Technical Exam List of Knowledge Categories. Let's get started with Section 702, Database Design. Database. A database is a collection of data that is stored electronically. Database server. A database server runs database software, which allows users and companies to store, manage, and access digital data. A database server is also known as a database management system. Clients. Clients are programs that access the database management system. Multi-tiered architecture. Multi-tiered architecture is the separation of data and functions into multiple levels. Database parts are easier to change and improve when they are separated. Databases can have any amount of tiers, but most are based on a three-tier system. A basic three-tier system consists of a user interface, application server, and transaction manager. A user interface is the upper tier. It is an interface that gathers requests from the user and passes them to the application server. The user interface tier is also known as the presentation tier. An application server passes requests from higher tiers to the transaction manager. It converts requests to instructions the transaction manager can understand. An application server can determine user access and roles. A transaction manager is the bottom tier. It takes requests from higher tiers. A transaction manager is part of the system that is known as the database to users. Database design. Database design is one of the most important roles of a senior GIS professional, as all organizations depend on accurate, reliable, and well-performing databases for managing assets, resources, and supporting all manner of operations and activities. Generally, the process is outlined as followed. Step 1. Determine the purpose of your database. Understand the goals and requirements for your database. Consider the users, data sources, and anticipated queries. Step 2 of database design. Find and organize the information required. Gather all types of information you want to record in the database. Identify the entities, objects, or concepts relevant to your domain. Define the attributes, or fields, for each entity. Step 3 of database design. Divide the information into feature classes and tables. Each feature class or table represents an entity or relationship between entities. Tables should be normalized to minimize redundancy and improve data integrity. Step 4 of database design. Specify primary keys and analyze relationships. Choose a primary key for each feature class and table. Define relationships, such as one-to-one, one-to-many, and many-to-many between tables. Step 5 of database design. Design the feature classes, tables, and fields. Determine what features need to be captured, stored, and what type of geometry is required. Will features need to be modeled for different scales? Determine the data types for each field. Set any constraints, such as required fields or unique values. You could also identify coded value domains. Step 6 of database design. Create views and indexes. Create views to simplify complex queries or restrict access to sensitive data. Define indexes to improve query performance. Step 7 of database design. Implement data integrity and security measures. Set up constraints, such as foreign keys, to maintain data integrity. Define security rules to control access to data. Determine if versioning is required. Step 8 of database design. Test and refine the design. Populate the feature classes and tables with sample data. Test queries, views, and data manipulation operations. Refine the design based on feedback and testing. Step 9 of database design. Document the database design. Create a data dictionary describing each table, field, and relationship. Document any business rules or assumptions. Step 10 of database design. Implement the database. Create the actual database using a database management system. Set up tables, relationships, views, and indexes. Conceptual database design. The conceptual database design process consists of deciding how data is organized, stored, and accessed in a database system independent of any specific technologies. The conceptual database design defines the structure, relationships, and constraints of the data to be stored. Conceptual models provide a high-level view of the database and act as a blueprint for designing and implementing the database. A logical database model. A logical database model is a representation of the database structure based on a specific data model that can be mapped onto storage objects supported by the database management system. A logical database model defines the database's overall organization, including tables and attributes. A logical database model defines the database's overall organization, including tables, attributes, data types, relationships, fields, domains, and constraints. A logical database model usually consists of an entity relationship diagram. Instance. An instance represents the current state of a database, including all records and their values. And now let's take a look at non-SQL databases. Non-SQL databases store data in a non-tabular way. Non-SQL databases typically have 4 categories of model stores. The 4 categories are key value, document, column, and graph. A key value database. A key value is the most intuitive non-SQL data store. Every data item in the database is stored as a key value pair. This is similar to a conventional dictionary. A key is typically a unique ID that points to the data with which it is associated. A document database. Document store is similar to key value store with one difference. It requires that its value store, called a document, be structured and encoded by metadata. Common encodings include XML, JSON, BSON, and for spatial data, GeoJSON. MongoDB and Apache CouchDB are examples of this category. Column store database. Column store supports data as columns instead of rows. This arrangement is usually optimized for queries over large datasets. Querying over rows is memory intensive and requires huge disk access, especially when each row contains many columns. With column store, columns are grouped into column families, and each column family can have an unlimited number of columns. In this way, it is much easier to query the entire collection of columns for all the rows. Google's Bigtable, HBase, and Cassandra are the most popular column store-based databases. Graph store database. Graph store is used to store network data consisting of nodes or entities, and edges or relationships, and properties of nodes and edges. Examples of network models include social networks, life science networks, road networks, and IT networks. In these designs, entities are highly connected through relationships. In relational databases, entities are stored as tables. Querying relationships between entities is done by performing join to those tables, an operation that is computing and memory intensive. In contrast, a NoSQL database, which enables graph store relationships, are the priority. Each entity contains a list of relationship records linked to other nodes. When performing a query to find those relationships, the database will use this list to find connecting nodes, therefore reducing time from searching and matching. Available graph databases include Neo4j, Infinite Graph, and OrientDB. A file system. A file system allows users to access small groups of data. File systems can store and retrieve files from a storage medium, such as a hard drive or cloud storage. Advantages of file-based systems. File-based systems are advantageous because they are easy to use, inexpensive, provide fast performance, and they are suitable for personal data management. Now let's discuss the disadvantages of file-based systems. File-based systems can be problematic because they have limited capacity, limited functionality, less security, greater data inconsistency, and they don't provide backup or recovery capabilities. A hierarchical database. A hierarchical database is a data model in which data is stored in the form of records and organized into a tree-like structure, or parent-child structure, in which one parent node can have many child nodes connected through links. Now let's take a look at some database components. Database components include data items, types, domains, entities, instances, records, relational tables, and files. Data items or attributes are indivisible named units of data. A type restricts the type of data that can be entered into a field. A domain restricts the values attributes can take. An entity is a collection of related data items. An instance is a specific entity. A record consists of related data items arranged in a row. Records are also called rows or n-tuples. A relational table is an organized group of records. A file is a collection of records. Now let's take a look at field types. There are many field types. Custom field types can be created by programmers. Some field types commonly used in GIS are short integer, long integer, float, double, text, data time, Boolean, binary large objects, object identifiers, and geometry. Short integers can contain values from 32,768 to negative 32,768. Long integers can contain values from 2,147,483,648 to negative 2,147,483,647. Floats can contain single precision floating point numbers. Doubles can contain double precision floating point numbers. Text can contain text. A date time field can contain calendar, date, and time. A Boolean value can contain binary values such as yes or no, true or false, or 0 and 1. Binary large objects, or blobs, store long sequences of binary numbers in a blob field. Blobs are good for storing images and multimedia. ArcGIS stores annotation and dimensions as blobs. Object identifiers store unique IDs and FIDs. Global identifiers store registry-style strings consisting of 36 characters enclosed in curly brackets. Geometry fields store spatial data such as point, line, polygon, multi-point, and multi-patch shapes. Open source relational databases. Open source relational databases include PostgreSQL, MySQL, MongoDB, and SQLite. SQL databases. SQL databases include PostgreSQL, MySQL, SQL Server, SQLite, Oracle, and Informix. MongoDB. MongoDB is a source-available, cross-platform, documented-oriented database program. MongoDB is classified as a NoSQL database product. MongoDB utilizes JSON-like documents. DB2. DB2 is a family of data management products, including database servers developed by IBM. It initially supported the relational model, but was extended to support object relational features and non-relational structures like JSON and XML. Microsoft Access. Microsoft Access was formerly Microsoft Jet Engine, or simply Jet. It is a database engine on which several Microsoft products have been built. It doesn't use a relational database. Versioning. Versioning allows multiple editors to edit one database by creating duplicates of the base data. Changes are recorded with addition and deletion tables. Versions can be created or deleted. Edits are isolated until an administrator merges changes. Edits can be posted to a parent version. Default is the root version. Now you know everything that I learned about database design to easily pass the GISP exam. Don't forget to thumbs up and subscribe to my channel so that I can keep helping people pass the GISP exam and achieve the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is an easily understandable, comprehensive, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.